The topic is understanding and deploying three-tier Node.js application, that is resume-matcher on kind, that is Kubernetes in Docker, exposing its NodePort via port forwarding, and we will understand the concept and apply node affinity, taints and tolerations, labels, and I will also perform GitHub Actions workflow to build and deploy image into the GHCR, which is GitHub Container Registry. But first, let's understand what is Kubernetes in Docker. Simply kind. Kind is an open source tool designed to run local Kubernetes clusters by using Docker containers as cluster nodes instead of spinning up heavy virtual machines to act as control planes and worker nodes. Kind packages an entire Kubernetes environment into a lightweight Docker containers. So when we hear about Kubernetes environment and running it, we think of Minikube and actual cloud platforms like AWS or Azure, and cloud platforms are paid. When you would run applications or deploy applications and run Kubernetes in it, you would have to pay for the charges on how much time you spent on. And also on Minikube, it takes quite time to spin up and start the Minikube cluster, and also Minikube offers single node architecture and it also takes quite a good amount of space to run it. Whereas Kubernetes in Docker kind is an open source tool designed to run Kubernetes locally and its clusters by using Docker containers as cluster nodes. So it would be a lightweight Docker containers acting as a cluster nodes. That was about kind, that is Kubernetes in Docker. Now, what is node affinity with respect to Kubernetes? Node affinity in Kubernetes is a scheduling mechanism that constrains or restricts which nodes your pods can be scheduled on based on the labels attached to those nodes. Simply, it is like a preference or requirements that attracts pod to specific machines or respect to the nodes specified in the cluster. And there exist hard constraint and soft constraint in node affinity. Soft is a soft constraint, meaning the scheduler will try to find a matching node. If no matching node exists, it will schedule the pod elsewhere anyway, meaning it is not strict. Whereas the hard constraint, this means rule must be met for the pod to be scheduled, and if no nodes match the labels, the pod will stay in the pending state. I will apply the hard constraint later in this video. The purpose of hard constraint is to ensure that workload is viable, cost efficient, and we follow the legal or regulatory compliance, because it acts as a strict guardrail for applications that simply cannot run or should not run on just any machine or nodes. Node affinity concept in Kubernetes is used with respect to hardware dependency, which is workload viability. Some applications require specialized underlying hardware to function. For example, GPU requirements. An AI machine learning model needs an NVIDIA GPU, and scheduling it on standard CPU node will cause the application to crash instantly. Also, for cost and licensing optimization and data sovereignty and compliance, meaning legal regulations often dictate the geographic and physical location of the user data. Geographic compliance, that is GDPR. European user data must be processed within Europe. So we can use hard constraint node affinity to force the pod onto the nodes physically located in the Europe West Cloud region. So it follows the geographic compliance GDPR standards. And for data privacy, some payment processing software might be legally required to run only on high security, single tenant or dedicated bare metal hardware. So node affinity hard constraint helps in those areas. That was about node affinity and kind. Now let's understand the importance of taints and tolerations in Kubernetes. Taints and tolerations is a similar concept to node affinity, meaning it is related to scheduling of the pod with respect to nodes, but taints and tolerations are quite different, meaning taints are applied to nodes. Think of them as repellent or the lock that restricts which pods can schedule on a node, whereas tolerations are applied to the pods. Think of them as the key that allows a pod to ignore a node's taint and schedule there. So taints are applied on the nodes, which makes them repellent to every pods other than the tolerations that are applied to it, and tolerations are applied to the pods. Pods that have tolerations applied can schedule anywhere and also on the nodes that have taints applied. So simply taints restrict every pods except the pods that have tolerations applied to it, and pods that have tolerations applied can be scheduled anywhere, even on the nodes that have taints applied. So it is to physically isolate workloads and protect the node health in a shared cluster. And there are many real world use cases with respect to taints and toleration. First would be dedicating expensive hardware, that is cost control. What if there exists a specialized node with expensive GPU for machine learning or massive RAM for databases? It exists for certain GPU resource allocation, not for regular applications. And what if a developer deploys a minor or a simple web application on it, and Kubernetes places it on that GPU node, wasting its resources and costing a lot in the cloud resources. So purpose of taint would be to apply it on the GPU node, which would be hardware GPU no schedule. Now regular applications are locked out, and that specific hardware or GPU resource is strictly reserved for actual machine learning workloads that hold the matching tolerations in it. And also to protect the system's infrastructure, that is cluster stability. We know that Kubernetes cluster has two components, that is control plane, that is the brain, and the worker nodes where applications run. What if a developer's web application has a memory leak and it crashes the node it is deployed on and takes down the Kubernetes master API with it? So the purpose of taints and tolerations would be that Kubernetes will automatically taint control plane nodes with the no schedule hard constraint, which guarantees that the user application never run on the cluster's brain, that is the control plane, which keeps the infrastructure safe even if the user's application crash. So simply it is to isolate the worker node applications that run on it to not utilize control plane for its use. That was about taints and tolerations, kind and node affinity. Now let's actually learn how I performed all this practically. First, I switched into the resume-matcher-DevOps root folder, and I performed the command to install the kind.exe, which is to install kind. I performed it with curl command. After it was successfully installed, I copied that exe file of kind and I pasted it in the local disk tools folder, and I deleted it from the resume-matcher root folder. Then I head back into the environment variables path and I added the tools/kind.exe folder into the path section of system variables. After doing it, I checked the kind version by kind.exe version, and it was successfully installed. After successfully installing the kind, now it was to set up the cluster or create the cluster. First, I created the kind-node.yaml. You can see the YAML file. It is a multi-node cluster with one control plane, 3 worker nodes. I saved that YAML and I performed the kind.exe command to create the cluster. Command is kind.exe create cluster flag name with the name of the cluster you want to name. I have named it kind node and space the config flag, redirecting it to the kind node YAML which I just created. Space image flag. I have provided exact image which I want to use of the kind, and it was successfully created. I confirmed it with the command kubectl get nodes -o wide, and one control plane and 3 worker nodes were successfully created, meaning cluster was successfully created. Then we have to perform the node affinity concept. So we have to label the nodes with respect to certain labels. So I performed the command kubectl label node a single kind node worker with zone equals east, and for other worker nodes it is zone equals to west, zone equals to central respectively. So now we have 3 worker nodes that are labeled east, west and central respectively. So it is easy for us to label them in the deployment file for checking and verifying the node affinity concept. After successfully creating the cluster and labeling the worker nodes with east, west and central respectively, now it's time to build and push the image into the GHCR GitHub container registry. To do so, the first step is to create the Docker publish YAML file. This YAML file is used to build and push the Docker image into the GHCR. That means I decided to perform and build this image via GitHub workflows, that is GitHub Actions. So I created that YAML file, which is Docker publish YAML, within the .github folder inside the workflows of it. So the root folder has .github folder. Inside that folder is the workflows, and inside that workflows folder is the Docker publish YAML with these specifications. As the name, build and push to GHCR branches is main. It runs on Ubuntu latest. Permissions are read for contents and write for packages. And here are the steps to build and push the image into the GHCR. After saving that YAML file, I also updated a Dockerfile so it supports the network configuration and timeout, so it efficiently performs the GitHub Actions. I saved the Dockerfile and I logged into GHCR or GitHub Container Registry by performing echo and a personal access token which I have generated to log in into the GHCR. Then to start the workflow of GitHub Actions, I perform this command on the root folder, that is git add space dot with git commit -m, that is message flag, which is featuring add GitHub Actions workflow for multi-architectural GHCR push and git push origin main. I performed this command and I checked into the GitHub account and actions. The CI pipeline for this workflow was successful and it took 13 minutes to complete it. And you can see the steps, that is set up the job, check out the repository, setting up of the QEMU, setting up the Docker builds, log into the GitHub Container Registry, extracting the metadata, tags, labels for Docker, build and push Docker image, post, build and push Docker image, post, log into the GitHub Container Registry, and all these steps until it is complete job. It was 100% successful, and we can observe within packages that resume-matcher DevOps image is successfully pushed into the GitHub Container Registry. We will use this GHCR image into our deployment file for deploying and exposing our application. After successful push of the image into the GHCR, next is to update the deployment file, which is resume-matcher-ghcr.yaml with respect to node affinity. So as I mentioned, I applied the hard constraint node affinity, which is required during scheduling, ignored during execution. Worth noting is the values. It specifies east, which means our deployment file specifies the label as east, so it will be deployed into the node that has the label east in it. So after this, I perform the command kubectl apply the deployment YAML file, and I performed kubectl get pods -o and pods were successfully running, meaning resume-matcher-ghcr deployment pods, that is 2 pods, are successfully running. Now let's confirm if it is actually running on those labeled nodes. So I perform the command kubectl get pods -l app equals to resume-matcher-ghcr space -o wide grep command, that is to filter out with respect to resume-matcher-ghcr filter. That command showed that the pods with resume-matcher-ghcr are successfully running, and it also showed the name of the node, that is kind-node.worker. Now let's see the label on that node. I perform the command kubectl get node kind-node.worker, which we just saw, and space the flag show labels with the flag grep zone, and as we can see, it is showing the zone equals east, meaning we have applied the node affinity in the deployment YAML file by specifying east as the node label, and now the application deployment resume-matcher-ghcr pods are running on that labeled node. That was about node affinity and running our deployment application pods on that node with east label in it. Let's confirm if the application is even running or not. Before checking it, I have created these configuration files. You can observe it. It has secrets, service YAML file, configuration YAML file, and 2 shell scripts as well. So you can observe the service YAML file. I have specified the image name with GHCR, GitHub Container Registry, and path of it. Then I created the secret by performing kubectl create secret Docker registry and naming that secret GHCR secret. Because the image pushed into the GHCR, that is GitHub Container Registry, is private. It is not public. So we must have GHCR secret which is specified in the deployment file, and that secret will have the personal access token in it. So that secret will have personal access token which will help deployment YAML file to access that private image pushed into the GCR. After successfully creating the secret, I perform the command kubectl apply -f space dot into the kind folder that has all these configuration files. All of these configuration files were configured after this command. Then I confirmed the services that is running with respect to resume-matcher-ghcr. So I performed the command kubectl get service with the name resume-matcher-ghcr services, and it was successfully running on the port that is NodePort. It has cluster IP address and ports. Then I performed the command kubectl port forward deployment resume-matcher-ghcr with port 8080 mapped with 3000. So now the application would be running on the port 8080. As we can see, the application is running on the port 8080. Now let's test the application. I uploaded the resume. You can see it shows the results, which is matched jobs. We can also observe the logs. It shows that the application is running. So by now we have applied node affinity with the label east. Then the pods with the deployment resume-matcher-ghcr were deployed on that label node, that is east, and the application was successfully running on that node. We have performed it with east label. Now let's change the deployment YAML file value with west. Previously it was label east, now we will do it west. So now pods, that is resume-matcher-ghcr pods, will be deployed on the nodes that has the label west in it. So I updated the deployment YAML file with west, and I created the node affinity check shell script, so it is easy to perform these commands. So the shell script has the kubectl restart of the deployment YAML, and to get the pods with the application resume-matcher-ghcr grep filter with resume-matcher-ghcr, and to show the label on the node by performing kubectl get node with the kind-node worker2 and show labels with the flag grep zone. I created that shell script. I performed and gave permissions to that script by chmod space -x and that script name, so it has permissions to execute it. By default it doesn't have permissions. And after that I ran that shell script by // with the shell script name, and we can observe that pods are now successfully running in the zone label west. Previously it was running on east, that is east label node. Now it is running on west label node. So that was about node affinity concept. We have successfully checked the east label and deployed application with respect to it, and we have changed that label from east to west and deployed application on that labeled node. Now let's understand the concept of taints and tolerations. For that I have updated the deployment YAML file by adding tolerations section in it. So we are applying the hard constraint, that is no schedule. So we have updated the YAML file with the toleration section. We have applied the key dedicated operator equal value db and effect, that is no schedule, which is hard constraint. We save that, and I have performed the command kubectl taint nodes with specifying the kind worker node 2 space dedicated equals to db with no schedule, and it was successful. It showed node/kind-node worker node is tainted. Then I performed kubectl describe node kind-node worker node space flag pipe grep taints. We can see that taint equals dedicated db no schedule. Now let's do the taint toleration script for the same, and this script has kubectl apply resume-matcher-ghcr YAML for applying the deployment of the YAML file and restarting it, and to get the pods with the label resume-matcher-ghcr, the grep resume-matcher-ghcr, and to describe the pod with the name kind-node worker node 2 pipe grep taints to filter out with that keyword taint. And I gave permissions to the script by chmod space -x, that is execute permissions for the script, and I performed and ran the script, that is /taint toleration.sh. Script was successfully running, and it showed the taints, that is dedicated db no schedule, and the application deployment files resume-matcher-ghcr was successfully running. It is because we have applied toleration section in the deployment file. If we remove the toleration sections from the the deployment file, then the application would be in the pending state because it is not exempted with the tolerations. To check that, I have removed the toleration section from the YAML of the deployment and I saved it. Then I ran the script again of the taint tolerations sh. We can observe that the taints is available, meaning it is dedicated to DB no schedule, and now the pods of the resume-matcher-ghcr are in the pending state because it doesn't have tolerations in it. Tolerations gives permissions to run even on the tainted nodes. Now let's untaint that nodes and see what happens. So I perform the command kubectl taint nodes kind-node.yaml dedicated equals db no schedule. Note that after this command there is a minus sign, which means it performs untaint. After performing this command, the node which we have tainted previously is now untainted, meaning there is no taints and the application would be running as usual. So I confirmed it by performing the same shell script again of taint tolerations sh. We can see the application resume-matcher-ghcr pods are running and there is no taints available or no taints applied. So simply if we apply taints into a node, that node becomes untouchable unless we specify tolerations that gives it permissions to access that tainted nodes to deploy on that tainted nodes. So by now we have understood kind, taints and tolerations, and we have also understood the concept of node affinity. So, and also we have understood GitHub Actions and we have applied, we have built and pushed into the private GitHub container registry, created a secret to follow the compliance and security. So we have dedicated a private registry to access images privately from that repository, and we have accessed that image by creating a secret GHCR secret which has personal access token which gives permissions or accessibility of that image into the deployment file and other service files within our clusters. So that is it for the video today. Thanks so much for watching. Have a great day. Bye.